All right. So I'm going to give us some practice problems for us to take a look at as we go through this last major topic of stoichiometry. We're going to take this over 2 weeks just because we're going to get the main stoichiometry done this week and then take a look at it a little bit more explicitly next week. But the first thing we need to talk about is mole ratio. All right. Mole ratios come from the balanced chemical equation. All right, so I've already balanced this one for us. And what a mole ratio is, there's a lot of different ways we can write it, but the mole ratio is just going to come from, and the reason why we took a look at balancing chemical equations. Now, the idea is this number, or this aluminum sulfate also has one. We would write a one right there, right? We don't need it in there for the balanced chemical equation, but for the mole ratio, we need a number. And so if I ask you something about mole ratios, which is actually going to come up a lot, I might specifically ask for this, but we are definitely, that's what stoichiometry is using this idea of mole ratio. Mole ratio is just a combination of any two of these in a ratio, in an equality to show us what it is we're needing or we're trying to find. So the first thing I take a look at is if we just wanted to have the mole ratio of, the reactants. All I would say is that I would have Na2SO4, right? And that's in a ratio compared to my AlPO4. And the numbers are just as follows, 3 to 2. Now what we can do with that is we can use those ratios of moles in any certain way. So depending on what we want to do, we might say, hey, we have 3 moles of Na2SO4 and we're trying to get rid of, that AlPO4. So we might see it like this. Or vice versa. So that would be 1, right? So just using those numbers, we could flip that to make it 2 moles of AlPO4 over 3 moles, right? Another one, maybe we're just taking a look at the products, right? And so we know that we have 1 versus 2. And so just writing it in the ratio form already, maybe I'm going to put my 2 Na3PO4. Oops, you know what I forgot? I need to write moles in there, making sure that's not grams, over my 1 mole of Al2SO43. So we could write that either way. That's another ratio. But it doesn't have to stop there. It's not just reactants and products separate. We could write a third one, and there's more. I'm just going to stop at 3, but we could write another one where we're kind of combining the two. So maybe I have it as I have 2 moles of Na3PO4, and I'm going to compare that to the 2 moles of AlPO4. Okay, so, and yes, I do want you to leave this ratio as 2 to 2, not break it down to 1 to 1, just keeping everything in line. Okay, so 3 different ratios, but we can make up about 5 others on there because we can flip them all and everything else like that. So that's part of finding the mole ratio. Pretty simple concept, just using, as long as you have a balanced chemical equation, it's just putting any two things together. So now what we're going to do is we're going to use that to solve this problem, right? How many moles of AlPO4 are needed to make 7 moles of Al2SO43? All right, so the idea is we want to know how many moles it takes to make. Even though this sounds different, that's why I wrote this. It sounds backwards because it sounds like, oh, we should make something equal this. Don't worry about that, right? It's just a math problem. We're going to start with what we know. So we're going to start with, we have our 7 moles of Al2SO43. Scooch that up a little bit. All right. Now what we got to do is we got to get rid of that. So this is no different, right? I'm going to put moles of Al2SO43 down there. Okay. Now this is the new part. That's why this is called the mole ratio. All right. So I have that guy. What I'm trying to get is I'm trying to get to that guy right there. So that's what's going to go on top. My AlPO4. Now this is going to be repeated a lot, but this is why this is called the mole-to-mole ratio, because the only way we can go from one type of a substance to another is through this mole to mole step. Okay, you cannot go from moles of one substance to grams of another, or from moles of one substance to atoms of another, right? You can only do that if you're within the same substance, which will come up. So what we have to do in order to cross over, in order to go from one type of compound or element to another type of compound, right? We have to do this mole to mole step. And again, all that is in this new stuff, it just comes from up here. So we're going from moles of AlPO4 to or from moles of Al2SO34, okay, to moles of AlPO4. So there's our ratio. So we're just going to write it down. So we have a 1 right there, and we have a 2 right there. Now, again, yes, I'm going to ask you to show your work. And yes, I understand that. I know you can do this in your head. All right. Either way, in order to get full credit, in order to not just make the 14 make sense, this is what I want to see. Okay. And we're done. That's it. That's how you use mole ratio. And that's the first step. It's not going to be the first step on every single problem, but that's the first step to really understanding how stoichiometry works, being able to convert from one element to another.